This diary will contain all the topics of signal and systems. This is the basic topic and you should know this before advancing to others. So let us concentrate. Today friends, we will start with playing with signals. So let me start with this topic, relationship between UT and delta T. See, UT, on differentiating UT, we will get delta T. Now, we just have to see where there is abrupt discontinuity. It is shown by this green arrow mark as I have shown on the screen. And I am looking from the left hand side. I have drawn I there. So, on differentiating abrupt discontinuity, that is UT, we got a impulse. The height of impulses, or I should rather say the magnitude of impulses, the change, that is 1 as shown on the screen. So what is the conclusion? Whenever an abrupt discontinuous signal is differentiated, we get an impulse at the point of discontinuity, and value of impulse is given by change in value of abrupt discontinuity. See, read this statement 2 or 3 times and you will get what I am trying to say. Now let us solve this question to enhance our clarity. Okay, so the question is on the screen. We have to write this given signal in terms of impulse function and unit step function. See, whenever you get this kind of function, that is unit step type, I hope you are understanding what I am trying to say. So first we will mark the abrupt discontinuity. So we will always look from the left hand side, and then the first discontinuity is shown as on the screen. The magnitude of this change is 1. Another, the magnitude of change is 1. Another, the magnitude of change is 1. And the last one is downwards. The value of the change is 3 here. See, I hope you get this. This is very important. First look on the abrupt discontinuity, see the change from initial to final, and mark the arrows. Now I will differentiate this, and we know whenever we differentiate an abrupt discontinuity, we get an impulse. So we will draw the impulses. First discontinuity, magnitude of impulse is 1. Similarly, see, at 3 the change is downwards, so the impulse will be in the downwards direction, and the change is final minus initial, that is 0 minus 3, that is minus 3. So that's why the magnitude of impulse is minus 3. This was xt in the question, and x dash t is the impulse signal. Now I will write this impulse signal. So what you have to do, just write the points at where the impulse lies. So first impulse lies at t is equal to 0, so delta t. Next one at delta at t is equal to 1, so del of t minus 1. Then delta t minus 2, delta t minus 3. Now we will write the magnitude of the impulses. First impulse magnitude is 1, second one is 1, third one is 1, and last one is negative, minus, so that's why minus sign, and 3. To find ut, as I have told you before, that on differentiating ut we get delta t. So on integrating delta t we will get u of t. So I am integrating delta t function. So x dash, the integration of x dash t is xt. On integrating unit impulse or impulse function, you get ut minus 1, ut minus 2 minus 3, ut minus 3. This you have to write directly. So the key point here is just see that abrupt discontinuity, then mark the arrows, find the change, and then write it directly as shown on the screen.